In this video, we will discuss how to read solubility curves. What a solubility curve is it looks something sort of like this, and typically they have a lot of different compounds labeled on them, so they look very confusing. But like this part, this line would be for potassium iodide, this red one would be for sodium nitrate, and so if you're only looking at a certain compound, then you kind of ignore the rest of them. And what they give you is that they tell you how many grams can be dissolved. The solute is just what's being dissolved in water. And then if we change the temperature, generally, we can write this down, generally, more solute will dissolve at a higher temperature. And that is for a lot of salts. But if I look at this graph, I can find, for example, ammonia. Ammonia actually has a negative slope here, which means that it dissolves less as you increase the temperature. Some of them are very small slopes, like sodium chloride, but if you look closely, you can see that the slope increases a little bit. And then some of them have really high slopes, like potassium nitrate here in blue. That slope's very high, meaning that if you increase the temperature, it really its solubility really does increase in water. So let's answer some example problems. Question A says, how many grams of potassium nitrate can be dissolved in 300 grams of water at 50 degrees Celsius? Okay, well, we got to first find 50 degrees Celsius, and that is going to be here. And so I will draw a line up, and what a lot of people might say is they might say that about 85 grams dissolves. So 85 grams of KNO3. But here's what's kind of tricky about these graphs is on the y-axis, this is for every 100 grams of water. So what I will typically do is I'll say, okay, 85 grams of potassium nitrate will dissolve in 100 grams of water. And this is, of course, at 50 degrees Celsius. So we got to figure out how many grams of KNO3 will dissolve in 300 grams of water. And hopefully you can see the math that we will just take this and we will multiply it by 3. And our final answer will be about 255 grams of potassium nitrate will dissolve in 300 grams of water, specifically at 50 degrees Celsius. Okay, so let's say we take that solution and we cool it to 10 degrees Celsius. Okay, it wants to know how many grams of potassium nitrate will precipitate out of the solution. And what that means is that at this level that we were at, we had 85 grams that could dissolve. And we're going to go all the way down to 10 degrees Celsius. So maybe I'm going to just estimate that. Maybe that's about 22 grams of potassium nitrate. And am I reading this right? Yes. 22 grams of potassium nitrate can dissolve in 100 grams of water. But we still have 300 grams of water. So just set up a proportion here. So 22 times 3, that's of course 66. So if I want to know how much will precipitate or will no longer dissolve, what that means is, well, 255 grams of KNO3 were dissolved, but I'm cooling it, so only 66 grams of KNO3 will stay dissolved. So if I take 255 and I subtract 66, I get 189 grams of potassium nitrate that will precipitate. Okay. Now, we have the same type of curve here, and what we want to do is label something as saturated, unsaturated, or supersaturated. Now, don't get overboard with trying to use supersaturated. That is actually a very rare thing, so don't try to use that too much when you're answering. I mean, it'll show up sometimes, but I'm just saying that realistically it doesn't show up as much as some people say. Now, we may see one here, of course. So saturated means that you've dissolved the max. Means you can no longer dissolve any more. There should really be two words. Any more solute. Unsaturated. Oops. Means you can dissolve more. And supersaturated, which we're not going to get into exactly how you can accomplish that in this video, but saturated means you have somehow dissolved more than what's possible. I'm going to put possible in quotes because there's certain ways you can go about making something supersaturated. So what we have in A is we've got 60 grams of potassium chloride and 100 grams of water, so that's nice because it matches our y-axis, so we don't have to do any multiplying. And we're at 80 degrees Celsius, so I got to find potassium chloride. And I'm going to use, I'll just highlight, we're at 80 degrees Celsius. We've got 60 grams of potassium chloride. So what I want to do is I want to say, okay, here's potassium chloride. Let me bring it over here. Okay, so we've got 60 grams of potassium chloride at 80 degrees Celsius. And if I look at my y-axis, the maximum that it could dissolve, that's what this line says. If you're on the line, you are saturated. If you're below the line, you are unsaturated, meaning you can still dissolve more. And if you're above the line, you're supersaturated. So 52 grams equals saturated. That is what's on the line. But we have actually 60 grams, and so it would appear that we're kind of up here. So that means that we're actually supersaturated, and I know I said that doesn't happen often, and I meant that more in terms of lab. It's actually hard to make something supersaturated, but these are just some paper questions. So this is supersaturated. Okay, now what if we have 80 grams of calcium chloride and 200 grams of water, which would be like 40 grams of calcium chloride and 100 grams of water, and we're at 10 degrees Celsius, so we'll need to find calcium chloride. Here is 10 degrees Celsius, and that looks to be about maybe 63 degrees, or not 63 degrees, 63 grams. So since we're at 40 grams, okay, that means that we are somehow, like right here, we're underneath this line. We are underneath that line, so that means we're actually unsaturated.